In this video, we will see how to automate machine learning with ProActive. Let's start by deploying a node source where the machine learning algorithm will be executed. A workflow has been pre-built for this purpose and requires a few parameters. We will use 4 nodes for our demo. Let's go to the resource manager and get some credentials to connect to the machine learning and deploy the node source. Let's copy the credentials within the workflow parameters and execute it. We can monitor its execution in the scheduler portal, as you can see here, and visualize the deployment in the resource manager. We can see 4 nodes deploying, which will then be available, and 1 node will be used to incite the machine learning libraries required for the demonstration. We can check from the scheduler interface that the libraries have been properly installed using Docker PS in our case. Now, let's train the model. Another workflow has been pre-built, which will use a folder of images to train the machine learning model. We can monitor its execution within the scheduler portal and see in the resource manager that 1 node is actually busy. Once completed, the model will be shared across all the nodes so that they can be used in parallel later on. In the scheduler portal, it is actually possible to monitor the execution and collect the logs of the workflow. By clicking on Fetch Output, it is possible to collect the log already written. And by selecting the streaming option, you'll be able to see the log live. As the training is taking a bit of time, we will skip to the end and show you the result. 50 minutes after, the model is finally trained, and we can see that 5,000 images have been put into the model, and we managed to achieve an accuracy over 90% overall. Now that the model is trained, we can do some prediction in an image. Let's select an image of rose and input the file as a parameter to our new workflow. This workflow is made out of 4 tasks that will be described later on. As always, we can monitor the execution in the scheduler portal, and we can see in the resource manager that 1 machine learning node is busy. In the scheduler portal, we can monitor the progress, seeing 2 tasks completed out of 4. We can preview the input images, and in the prediction task, in the logs, we can see the result of the prediction. In our case, we will see that it is a rose at 98%. The last task is actually giving a preview and putting the result onto the picture. Now, let's repeat the scenario with another flower type. Let's input the new file name and file path as a parameter to our workflow. So now I'm copying the file name. I'm going to the workflow, executing it, and in the parameter, I will change the file path to sunflowers and change the image name to the one that I copied. I can then execute the workflow. We can visualize the workflow running in the scheduler portal and see that 1 machine learning node is actually busy. When I go back to the scheduler, we can visualize the input in the browser, as you can see here, and we will wait for the prediction to happen. I can see the progress of the execution in a visual way or as a table. When I fetch now the output, I will see that the sunflower is expected at 99%, and on the outputs that I will visualize on the browser again, we can see that it added the right numbers. Now let's do some parallel prediction. We will execute 4 times the same workflow and visualize that the 4 machine learning nodes are busy. I'm executing 4 times here the workflow. I will visualize in the ProActive scheduler portal the execution, and we'll see right now that the 4 nodes are busy. Now I need to wait that the process is completed I can select one and visualize the input. And wait for it to be finished to visualize the output. And when it's finished, all the nodes are then free. Now, let's select another workflow that I prepared before and execute it. This will fetch 3 images and do the same machine algorithm into each of them. As we can see, we can visualize the progress of the workflow. We can visualize in the resource manager that 3 nodes are actually busy. And then we will visualize first the input of each of the branches. As we can see, each input is a rows, so the machine algorithm should find a rows in each of them. Let's see the output. A rows, another rows at 94%, and a rows at 100%. In the resource manager, we can see that all the nodes are then free. Let's do some image classification. Now, let's integrate this algorithm in a more complex use case. We have a folder full of various images, dogs, cars, rockets, and we want to sort them by category. We prepared a workflow earlier on that when we execute it, we'll sort all of these images into folders. As always, we can monitor the execution into the scheduler portal. And in the resource manager, we will see that one machine learning node is busy. When it's complete, all the images are then associated with the folder. In a more advanced concept, let's look at object detection. As usual, we will execute a workflow with some photo, and the goal will be to identify in the photo what are each object. Here, let's visualize what is the input. And as you can see here, we have a dog, a bike, and a car in the background. Now we need to wait for the algorithm to be completed and visualize the final output. As always, in the scheduler portal, we can stream the output and visualize the progression of the algorithm. Let's wait for the output. It's done, so we can visualize it. And as I said before, the algorithm detects a truck, a bicycle, and a dog. Now, in another context, let's look at anomaly detection. We will input an image first, a normal image with nothing to detect, and see if there is a problem. We download the data first, then we have a task to give you a preview of the image. As you can see, nothing is happening in this street. So the machine learning algorithm should tell us that there is no anomaly detected in this case. So let's wait for the output. Now when I preview the output, I can actually see anomaly not detected. Let's close it. Now let's execute another workflow with actually an anomaly, just to show you how the machine learning algorithm behave. So as always, we download the data first, then we can preview the input. As you can see, there is a car in a pedestrian street. You can visualize the execution. And then on the output, we can then visualize that there is a car detected. Now that everything is completed, we can delete the node source and free up the resources. So as always, we have a workflow pre-built, so you don't have to do much. We just fill in some parameters such as number of nodes. We execute it, and we'll see the nodes disappearing. We now have the resources free. Please try the solution on our Try platform, link in the description, and do not hesitate to comment and get in touch for more complex solutions such as ensemble learning or any machine learning use case.